It can be appreciated that data can be utilized to find solutions to problems, track progress, monitor initiatives and efforts, and ultimately make informed decisions. Unfortunately, data generally tends to be locked away rather than openly accessible, residing within organizations at the national and local levels, and even within organizations beyond the borders of our countries and regions. We need to recognize the power of unlocking and bringing together pertinent and up-to-date data to create value-added products such as maps and other visuals to allow for better decision-making. The data and mapping component of the Caribbean Protected Areas Gateway Resource and Information Hub seeks to address this through the use of GeoNode technology, which provides the infrastructure to discover, publish, and manage spatial data in the form of layers. Utilize mapping functionality to create maps, as well as access and build upon existing maps without the need to have GIS or mapping expertise, and also to develop and promote a community of data providers and users. Data can be accessed and discovered via the layers component. We can see that there are 28 distinct layers, each of which can be explored to gain a better understanding of the dataset. Included the associated metadata. New or updated data can be uploaded by users who retain all the rights to their data and can manage it by setting the relevant permissions. Who can view it, who can download it, who can change the metadata for it, who can edit the data layer, who can edit styles, and ultimately who can manage it to update, delete, change permissions, publish, unpublish, etc. This thus allows for the publishing and, in essence, the backing up of data, which then may be viewable and accessible to all users, viewable but not downloadable to anyone, are only viewable and accessible to a group of persons, for example, those within an organization, or only to the person uploading the data. The uploading of data requires the mandatory addition of metadata in a standard format, which includes the identification of any restrictions on the data, such as licenses. The access to and discovery of data is enhanced with the provision of mapping functionality, which allows the overlaying of data layers on several base layer styles based on personal preference. For demonstration purposes, I'm going to use the satellite imagery base layer, and I'm going to search for data layers pertaining to Belize. Because the satellite imagery does not provide country boundaries, and I know one exists for Belize, I will add that first. Based on available data layers associated with Belize, we can investigate where the terrestrial key biodiversity areas are. So we can see the key biodiversity areas shown as orange polygons. Naturally, we may want to visually see how much of these areas are protected based on established protected and conserved areas. We can see that most of the key biodiversity areas are protected, the protected areas being indicated by the yellow polygons, but there are a few biodiversity areas without protection from protected areas. So we can see there's still some key biodiversity areas that are without protection. Now, one of the things that Belize has done is to establish biological corridors to link the protected areas. And we can add these to investigate how they correlate with the established protected areas. We can see that these corridors, shown as blue polygons, do in fact allow for a level of connectivity between the established protected areas. We may then want to investigate existing pressures on the key biodiversity areas, and one of the ways to do that, based on the available data, would be in the form of road pressure. If we remove the protected areas layer, we can see for the most part that the road network, shown as gray lines, avoid these key biodiversity areas. Except for this area here, primarily, there is a lot of road network or road intrusion into this key biodiversity area. Now, another potential pressure worth investigating is that of settlements. So we can add this layer to see how these areas correlate with the key biodiversity areas. The settlements are shown as green dots. You can definitely see how the road network correlates to the settlements. Within this key biodiversity area, we see there are some settlements potentially identifying the need for the road network. However, in this key biodiversity area, we can see there's only one settlement yet, a lot of road network and road intrusion. So perhaps something to investigate or to look at as the management authority. Another relevant pressure that we could also take into account is that of protected area downgrading, downsizing, and degazettement, known as PADDD. This is global, so it's not tied to Belize, so hence I have to do that. So if we remove the road network, the biological corridors, and the settlements, we turn on the protected areas layer, we can now see represented as orange polygons events of protected area downgrading, downsizing, and degazettement. One of the functionalities of the platform is that it allows you to query the various data features and data layers that are being displayed. So for example, we can see for this event, this occurred in this particular protected area. The event type was actually a downgrade. The protected area was downgraded. Protected area was gazetted in 1994, and the downgraded event occurred in 2012. Of course, your investigation or development of your story can continue and be altered based on your interests and what data are available. For me, my next step will be to extract useful information for input into a report. My preference would be to use an empty base layer to remove the background noise for inputting into the report. Now, in addition to the mapping functionality, the platform also provides the ability to generate charts and tables based on the data in the map. Let's say I want to report on the size of the key biodiversity areas. I can generate a table with that information, which could then be exported for inclusion into the report. So here we have the table generated. As we can see, it provides information on the key biodiversity areas and the size of those areas in hectares. Now, as you would appreciate, the map is interactive, and so is the functionality. One of the things we'll recognize is as I zoom in and out, the table will automatically update based on what is in the field of view. So with this table, I can export this table and add it in to a report. Apart from the KBAs, I may be interested in the protected areas. For example, what percentage of protected areas fall into each of the IUCN management categories? In this case, I'm going to create a chart, a pie chart, with the various IUCN categories. So for example, I can see that category 4, out of the protected areas, there are 67 or 42% of the protected areas are within this category. Now with this, I can actually see that the chart data, just for verification or investigative purposes, and I'm then able to export the image for use in a report. I'm also able to download the underlying data used to generate the chart. In addition to the breakdown of protected areas by categories, I may also want to report on the average size of protected areas within each category. In this instance, I'm going to use a bar chart. I'm going to generate the average size. And my personal preference, I like to remove the grids at the back, simply as background noise. So this is the mean size of protected area based on management categories. And once again, I'm able to generate this chart, which identifies the mean size of each of the management categories. So I can see that protected areas within category 1A on average are largest for Belize, whereas protected areas in category 3 tend to be smallest. Once again, I can show the chart data if I need to actually get actual numbers or to investigate. And again, I can then export this image for use in a report or download the data. Now regarding the map, it can be saved and published, potentially allowing other users to access and build on it. I would probably title this as Protection of and Pressures Exerted on Key Biodiversity Areas within Belize. The functionality also allows for the measurement of distances. For example, I can measure a line or a path. Of course, I can alter the units. It also allows the measurement of area of a given feature that I may be interested in. And it also allows for the measurement of bearings based on features on the map. And of course, the functionality allows for the map to be exported and included in any report, complete with a legend and a scale bar. Of course, I can also decide the quality of the output that I'm going to include in the report. So, of course, for this to work, it really hinges on you to be part of our growing community of data providers and users to ensure that relevant, accurate, and up-to-date data are accessible to allow for better reporting and decision making.